Hello everyone, welcome back to my channel. My name is Piyush and this is video number 11 in the series Azure DevOps Zero to Hero. In this particular video, we'll be focusing on Kubernetes. We'll be implementing an end-to-end project in Kubernetes with the help of Azure DevOps CI/CD pipeline. And before starting this video, however, I would like to share a funny incident with you that happened recently. So I was watching this video and the content creator on the other side, he was explaining how he did the deep dive into Kubernetes and AWS within 2 months. And earlier I thought he was making a meme out of it. Maybe it was, a funny video, not informative, but a funny video. But then when I watched it again, I found out that he was being serious. And that raises a lot of question in my mind. Like, as a content creator, isn't our job to provide the clear and concise details to everyone who's watching our videos? And is it not our duty to make sure that we provide correct information based on facts and not based on perceptions, right? So then I thought, maybe I'll give you my example. Like, I've been in IT for more than 12 years, and for the past 6 years I've been working with DevOps and cloud. I've worked with AWS, Azure, now working with GCP as well. And for the past 2 years alone, my day-to-day job is on Kubernetes itself, like Google Kubernetes Engine and Anthos. And even after those 2 years of complete hands-on day-to-day, I cannot say that I have done deep dive into Kubernetes, because it is that vast. No, you cannot just gain expertise in Kubernetes within a few months or maybe a year or so. Maybe a year for some folks if you are extra brilliant, but I'm not that brilliant. I'm just an average guy, so it took me some time. And even now, after 2 years, I can say I know maybe 40-50% of Kubernetes and not more than that. So I'm still not sure how someone can do that in 1 month or 2 months. Kubernetes is not a piece of cake, right? So I believe this is my responsibility to not give you the false hopes. That I'm not saying that after watching this video you will be proficient in Kubernetes, because that would be just giving you false hope, which I don't want to do that. I cannot teach Kubernetes. I cannot even cover the fundamentals of Kubernetes in 2 hours, 3 hours, or maybe 5 hours, because Kubernetes is just, it's a giant, it's a beast. We cannot cover that into just a couple of hours or so. So yeah, so just wanted to share that with you. And if you have come across any such scenarios, let me know in the comment if you think that it can be doable, or if you think, like, what should be the average time you think should spend on Kubernetes to gain a certain level of expertise. Maybe how much time it will take to clear the fundamentals, or to gain an intermediate level of proficiency, or to gain the expertise level of proficiency. Let me know in the comment. I would like to hear your thoughts on this. So yeah, with that being said, let me start today's video. But again, I'm saying this, today's video is about the fundamental concepts of Kubernetes. I'll try to explain the Kubernetes architecture, fundamental concepts, and then we'll implement the project into it. I cannot cover everything within just next 30 minutes or even 1 hour. So yeah, just wanted to set the expectation right, and let's go ahead to our GitHub repository and see the agenda for today. All right, so I'm in my GitHub repository. You should already have the link by now. If not, you know where to find it. So I have scrolled down to the section where it says Day 11, implementing CI/CD using Azure DevOps on Kubernetes. So we'll start with the basic introduction of Kubernetes and its benefit, like why do we actually need it. And it's a continuation to the previous video in which I have explained the basic concepts of Docker. So make sure you watch that before this one. Then we'll do, I'm not going to say deep dive. Then we'll look into Kubernetes architecture. So all the different components of it, what is control plane, all the components. We'll look into different type of nodes, master node, worker nodes, how they are different from each other. Then we'll see some basic stuff like what is deployment, pod, service, and so these are the things that we'll be using in our demo after this. So we'll discuss on that, and then we'll implement the CI/CD pipeline on Kubernetes. We'll be using AKS, Azure Kubernetes Service. We'll implement 2 clusters, one for staging, one for production, and then we'll deploy the end-to-end application on staging, then promote it to production. Because I have already explained the build process from Docker file to how we create Docker image and then how we run container in the previous video, I'm not going to explain that in this video. So in this video, we'll be focusing on the deployment part of it, like how to perform the deployment using Azure DevOps on Kubernetes. The sample application that we'll be using is a real-time application. It's an online banking application by Google Cloud. It's called Bank of Anthos. It's a microservice-based architecture. There is one more incident that I would like to share here. So recently, I have seen some social media posts where people are implementing the project. It's a good project. It's an online boutique application, again by Google Cloud, but people have been calling it 10-tier application. So I would just like to emphasize on the fact that it's not 10-tier application, it's a 10 microservice based application. So there is a difference between tier and microservices. Again, it's our fault as a content creator that we did not provide enough details or the correct details when we were sharing those details as part of the video, but just wanted to share with you so that you get the idea about it. So again, yes, there will be several microservices in this online banking application, and I will try to include the basic introduction of microservices as well in this agenda. So there will be some microservices in this application, but it's not a 10 tier. It will be like 3 tier, a front end, a back end, and a database, and there will be several microservices that will be running as part of these services, right? So we'll implement those, but before that, let's get the basics right. Let's understand what exactly is Kubernetes and why do we need it. So let's continue our previous discussion with Docker containers. So running your services or your application as single Docker containers on something like Azure container instances or any container based managed service, it's fine when there are, like, let's say 4 Docker containers. But let's say, and yes, they are running on a virtual machine, on a single virtual machine, but let's say if one of the Docker container goes down, it crashes, so you as an administrator logs into the virtual machine, SSH or RDP into the virtual machine and maybe fix the Docker container and it comes up healthy. So this is fine in case of a small application, let's say just a few Docker containers running, maybe your non-prod environment or something that you have set up for your testing and learning purpose, that is fine. But when you scale it from 4 to, let's say, 100 or thousands container, then how would you manage these tasks? Like, even if you have a team of administrators, it would be impossible to keep all the services up and running all the time. Let's say there'll be multiple containers crashes at the same time. So how will you fix it? It will be an inefficient way to SSH or log into the virtual machine and fixing those containers manually one by one. That's not something, a very efficient way to do it. But if your virtual machine goes down, that means the underlying host operating system goes down, your entire application suite will go down. And we are talking about an enterprise application that cannot tolerate any downtime whatsoever. So how will you manage that in case it is running as part of a managed container service or just as a containers running on a virtual machine? So in that case, so your entire application will goes down, right? But if you want to deploy a newer version of a Docker container, let's say version 1.0 of any container, like let's say an Nginx container, how will you efficiently do that considering there are thousands of containers running? How will you expose your application to the end users? You cannot have one single load balancer redirecting everything to these many containers. So there are these many challenges, and there are a lot more challenges with the containers itself when you scale it, right? Other challenges include, what about container networking? How will they communicate with each other? How about resource management or security or high availability, fault tolerance, service discovery? There are a lot of challenges, right? And this is just the tip of the iceberg. I'm not even explaining everything. So to overcome from all these challenges, to make sure that we run containers efficiently and effectively in a cost optimization way, and considering all the benefits that we can get from the container, the answer to this problem is Kubernetes. Kubernetes takes care of all of these things, including some other things such as scalability and load balancing. There are a few more. This is why we call Kubernetes as a container orchestration, right? Because it takes care of everything. Now, the other thing to remember is Kubernetes is not always the solution. Like, as we have seen before, if your application is running small workload or just a couple of containers, or the application can tolerate downtime, it does not require high availability or fault tolerance or anything, it would be better to stay away from Kubernetes, because it also involves a huge learning curve, a huge responsibility of making sure we are efficiently using it. Otherwise, we'll just end up paying a lot of cost to the cloud providers. So make sure you analyze your use case first, whether you actually need Kubernetes or not. So let's have a look at the Kubernetes architecture. So Kubernetes is a combination of multiple nodes or multiple virtual machines, and it has a control plane or a master node, and it has one or more worker nodes. In a production grade environment, in an enterprise architecture, we usually deploy our control plane or the master node in multiple regions. So there are multiple master nodes. Don't worry about it. I'll explain everything, what is node and all those terminologies. So just wanted to give you a brief introduction, but let me explain it to one by one. We'll just break down these components. So let's say you have control plane or the master node, and then you have two worker nodes. So this control plane or the master is the brain of Kubernetes. So it is a node. So node is nothing but a virtual machine. So it is a type of node where all your administrative and operational workloads are running. So these workloads are a combination of many control plane components. We'll see those components as well. And these basically instruct the worker nodes to do the actual task, to run the workload, and it takes care of all the things, high availability, fault tolerance, Kubernetes networking, and everything will be done inside this control plane or the master node with the help of different components. And then we have your worker nodes. So worker nodes is where all the heavy lifting takes place. It runs your workload. Let's say you want to create a Nginx container. So it will be running on the worker node. Control plane and its component make sure it is up and running all the time, make sure it is running on the correct node, and make sure all the details are stored in the cluster itself, but it will be actually running on the worker node. So it will do all the heavy lifting for you. The first component of control plane or the master node would be API server, right? API server is the central application or is the central service which receives all the requests from within the cluster and from outside the cluster. Let's say you are a Kubernetes administrator, right, who wants to log into the cluster. So you interact with the cluster with the help of a command line utility called kubectl or from the Google Cloud Console, and you interact with that. Let's say you fire a command kubectl get pods. So that commands get translated into a RESTful API, and this API is exposed by the API server. So API server communicates internally with all the other components, controller, manager, scheduler, etcd, and it provides you the desired output. Let's say you want to list the pod, or you want to run the pod, or make any delete or update operation. All those will be done by API server. So it is the point where every communication happens, like it receives the request and it forwards the request from outside the cluster and internally from the cluster as well. The next is kubescheduler. So kubescheduler make the scheduling decision, right? So it watches for new pod and it schedules the pod on a particular node, like based on constraints, resource constraint. Let's say this worker node running over here, it does not have sufficient CPUs or memory to provision a particular pod, right? So that decision will be made by a scheduler, and it will assign the pod to this other worker node because it has the sufficient resources. Right? So this is the job of a kubescheduler. Next is controller manager. Controller manager watches the desired state of the cluster. It checks and makes sure all the workload, all the pods, all the objects are up and running, they are healthy, and it makes sure that whenever a pod crashes, whenever a container crashes, it restarts that container. So it makes sure that cluster remains in that desired state all the time. So that's the function of a controller manager. The next is etcd. Etcd is a key store database. It stores the state of your cluster within a database, right? It has all the details about your cluster, including all the operations, including all the API calls. Every single detail of the cluster, including the configuration, gets stored in the etcd database. This is really important to have the control plane components be up and healthy all the time. And that is why we deploy a control plane into multiple nodes in multiple locations, so that even if one of the components in one of the nodes, if it gets down, due to several unforeseen circumstances, even then it will be available through other nodes. So that's it. Then we have worker node. So the components of worker node will be one or more Kubernetes objects. So these objects are like, let's say, pod. Now let's drill down into pod. What exactly is a pod? I have not introduced this term yet. I have been referring to this as a container, but actually in Kubernetes, pod is the smallest deployable unit. What I mean by that is when you run a workload, you actually run it as part of a pod, not as a container, as part of a pod. and inside that pod you can have one or more containers run. Ideally it should have only one container. Let's say you want to run an nginx container, right? So you create a pod. Inside that pod there will be one container which is nginx container, so that's okay. But there are certain cases in which you need to inject a sidecar container or a init container within the same pod, and in those scenarios we have multiple containers running. So what are sidecar or init containers? So let's say you want your container, the primary container, you want it to be up and running after 30 seconds, right? So you create an init container and add a sleep 30-second commands in that container. So init container will be executed first, it will sleep the pod for 30 seconds, and once that 30-second period is over, then the nginx container will start, and there are several other cases, like for monitoring for htio, we inject the sidecar container as well in pod, but that is beyond the scope. This is the fundamental video, so I'm not going to cover those. But just understand this: pod is the simplest and the smallest deployable unit in Kubernetes. It can run one or more containers. So then we have kubelet. Kubelet receives the request from API server. Let's say you want to start the container or you want to stop the container. So you make that request with the cluster with the help of an API server. Okay, so you do that with the help of kubectl command, and that kubectl command interacts with kubeAPI server, and then kubeAPI server sends the request to kubelet, and then kubelet takes the action to start or stop that pod. So kubelet's job is to make sure that it receives and sends the request to kubeAPI server, and to make sure that all the operations are getting performed in the pod itself. So that's what kubelet does. Then we have kubeproxy. Kubeproxy makes sure that your connectivity and your networking within the pods are enabled. So it makes sure that your pods can interact with each other. So that's the job of a kubeproxy. Then we have a deployment. So deployment is nothing but an identical copy of a pod. So let's say you were running an nginx container. What if that container goes down? Yes, we are using Kubernetes, so it will restart the container, but till the time it is restarting that container, your nginx application will be inaccessible to the users. So to make sure this doesn't happen, what we do is we create the identical copies of nginx containers and call it collectively a deployment, right? So deployment is nothing but a collection of identical pods running as part of one single object. So even if nginx container 1 goes down, it provisions a new container, nginx 4, and your application will always be accessible. So that's what a deployment does. So these are pods and deployments, but we have not exposed our application to external user yet, right? So what we do is we create a service within Kubernetes. Service, there are different type of services. There is cluster IP. Cluster IP makes sure that your services are internally accessible within the cluster. Then we have node port, in which we expose certain ports within the cluster. Then we have a load balancer service. So load balancer, when we have to expose a service, a deployment externally to the user outside the cluster on a public internet or in an authorized network, then we used a service of type load balancer, right? So this is what we're gonna use. So these objects, these all things we're gonna use in this demo. That's why I thought it would be better if I explain it first before we start the demo. Right, I am in my GitHub repository and I'm inside the Day-11 folder, which has all the instructions. It has most of the instructions and some application code as well that you can reuse. So I'm inside that repository, and as part of this demo, the prerequisite is to provision the infrastructure. Like for every other demo, we first set up the infrastructure, right? So because this is a Kubernetes based lecture, we'll be implementing a Kubernetes cluster in which our application will be hosted. Then we'll also provision an image container registry, ACR in this case, Azure Container Instance Registry, and in that we'll be uploading the container images for our application. It will also have a SQL server, and it will host a SQL database to store the database information. So this is a 3-tier architecture, and here is the application code as well. Because there was no official GitHub repository for this, I have imported this from one of the Azure DevOps demo labs, and it has everything. So here is the application screenshot. So this is my healthcare or healthclinic.biz, This app was maintained by Microsoft community, and it has, like I said, it has a front end, a back end, and a database. It has like these screenshots of the application, and this has been implemented on containers, and application database will be a managed database service hosted on Azure. So yeah, this is where the application code is hosted. We'll import that in our Azure repos. I will show you the steps. Yeah, so this is, like I said, a 3-tier application, a front end, a back end, and a database. So as part of the first step, for infrastructure provisioning, you can either use this script. This is a shell script that I have written, and it basically has a few AZ-CLI commands like create the Azure resource group with AZ group create the AKS cluster, create Azure container registry, then authenticate your Azure container registry to AKS so that AKS will have access to pull and push the images, and then to create SQL Server and database. You can provision these resources from Terraform. We have already covered Terraform in detail in, I believe, video number 8. You can follow that and create a separate pipeline for infrastructure provisioning, or you can create manually from the portal, or you can use this script and run this from the Cloud Shell. So this is what I'm doing. I have copied this, and I'll go to my Azure portal over here, and I'll open the Cloud Shell. So here is the Cloud Shell. This is an integrated shell within Azure portal. It has access to your Azure environment, and you can run all the commands on your Azure portal with the help of this Cloud Shell. So yeah, so this is requesting a Cloud Shell now. Okay, over here let me create a directory, dir demo11. So this will make a new directory, and I'll then change the directory with change directory cd into demo11, this directory, and I'll open a vi, and let's call it create infra.sh. To provision the infra, I'll go in the insert mode by pressing I, and then I'll paste the content that I have just copied from the repo. Okay, so our script has been copied. I'll close this with :wq!! I've created the script. Now I'll just provide the execute permission to this with the help of chmod 775, and then I'll just execute the script. So this script will provision all the resources for us, all the resources that we have just saw. So if I go to my resource group, currently I don't have any resource group created for this demo. I'll just scroll down a bit. These are all the resource group that it had previously, and it hosts basically the Cloud Shell storage, this one, and that's it. So currently it has 3 resource group. There will be one more created for this demo, and there will be other resources. We'll see that. So this will take around 10 minutes to provision the infrastructure. So while it's doing its work, we can go back to our Azure DevOps project. We'll create a new project, we'll set it up, and we'll walk you through the Azure DevOps pipeline for this particular demo. So I'm gonna create a new project. Okay, and let's give it a name, demo11 AKS. Okay, hit create. So that's the first step. If you want, you can use the existing project. It's totally your choice. And then you can go to repos, and now we'll be importing the GitHub repo, which has the application code and all other files. So I'll go to this particular repo that I have created, and it has the application code and everything. So I'll copy this, go to Azure repos, and scroll down where it says import a repository, right, and hit import. Now enter the URL, and I'll just remove the last few strings till the GitHub repository, and then hit import. Now this will import a repository in Azure DevOps so that we can use it. Okay, so it says import is successful. Now everything is here. Now you can edit the existing pipeline, or then you can create a new one. In any case, I will show you how to do that. So let's go to the pipeline section and hit create pipeline. Okay, where is your code? the code is on Azure repos git. Select this, and this is the repository, and it has already imported the repository because it has the Azure pipeline.yml. So this syntax you are already aware of. We have seen that multiple times in previous videos. If you are watching this video for the first time, I would highly recommend going through the previous 10 videos of this series, which has the entire detailed section of this. So, oh, by the way, if we go back to our GitHub repository, right, it has a few more prerequisites. First is you need to have these two extensions installed, replace token and Kubernetes extension, because I have used that already. So it's already installed in my project, but in my organization, sorry, it's at the organization level. But if you are using it for the first time, then you can install these two extensions, and then it will be visible over here in the show assistance section over here, right? So going through the pipeline, so first is a trigger. So there will be a trigger on the master branch or on the main branch. Then it will use a Ubuntu latest image for building and everything. Then the first step is replace token. What exactly is this? Let's go back to, I'll open this repo in a new tab. Okay. And so there'll be certain files that are standards that are used as templates, right? For example, this YAML file. In Kubernetes, we have YAML files, right? For the deployment, we have already seen deployment, services, and pods. So this particular file is a deployment, a pod, or a service. So we basically write a YAML file. You go inside that file, there are few details, right? So first, this is deployment. Then if you scroll down, you will see there is a service. Then there is another deployment, which is the front end, MHC front. And if you scroll down a bit to the section where it has image, so the image is tokenized over here. What I mean by that is we have not hard coded any Azure container registry, because it will be different based on your project, based on your Azure container registry address, right? We'll be creating a separate registry. We are not using any public registry. So that is why the ideal case is to get the build pipeline, replace that token for you at the runtime. And this should not be hard coded over here, right? So there are different formats of using the tokens. First is, double underscore at the beginning and double underscore at the end, and in between those there'll be a variable, which is ACR. So this is the standard file. So that is why we have created a separate step for that, which is called replace token. And how do we create all those details? So you click over here, show assistant, and search for replace token, right? So this particular step, and you enter all the details over here, like root directory. For us, root directory is the current directory. Inside the root directory, there is mhc_aks.yaml, right? So that is your root directory. Then we have the target file. Target file, if you see, we have the target file name as app_settings.json. So this is a separate token. And then there is token pattern. Token pattern is what we are using is this one. We need to select this one. So I'll just cancel this task. Okay, let me cancel this. I'll minimize this. Okay, so if you want to update over here, so what you can do is you can click on setting, right, and it will open the already filled information for you so that you can make your changes. So the first step is replace token for app settings. App settings is where we store our database credentials, right? So this will be inside the source directory. So if we go to our Azure repos, inside the source directory, and inside that myhealth.web, this particular folder, there'll be an app settings.json. Inside that, there'll be some tokens. So this token, SQL Server and SQL User, SQL Password. So there are 3 tokens that we need to replace. So for that, you first select the root directory, target file, and then select the token pattern. Pattern is this one. Okay, and keep everything as default. Now, how do you make the changes? Like what values should it be replaced with? So you go inside this variables. Currently, there are no variables that are being stored. So you click on new variable. okay, and you basically enter all those details over here. So we need ACR, that's one. I'll update the values later on. So one is ACR, then another one is SQL user, then we have SQL password, then we have SQL server. Okay, I believe these four. Let's save this. Okay, and once you enter all those details, you can click add. Once you do that, this will be added over here. Okay. So that was the first step, replace token for app settings.json. The second step is replace token for the other file. So again, you click on settings, or you can create a new task. Your root directory, if you are in your root directory already, then you can leave this blank. And the file is this mpcs.yaml. So this is correct. And keep everything as default and make sure the token that is there in the file, there is a variable existed for it, right? So which is ACR. Then we have Docker Compose. Okay, first let me show you the steps that we are performing in this particular pipeline so that it will be clear to you. So if we go down to our Day-11 folder, right? So here are the steps. First is replace token that we have already seen. We'll be replacing tokens in these two files. Then we have run services. So we are using a tool called Docker Compose. If you are new here, I'll create a separate video because it will be hard to explain everything about Docker Compose, Helm, and all those Kubernetes related concepts in this single video. It will be a lengthy video then. So I'll explain that in a separate video, but for now just understand Docker Compose is a YAML file in which we add multiple Docker containers, right? Let's say you have 10 Docker containers and you have to start the container. So instead of starting those 10 containers one by one, you can enter all those details inside one Docker Compose file, and then you can do Docker Compose up to start all those containers together. This is the first command, which is a run service which helps you prepare a environment for you with the base image and every packages that are required for the build. So let's look at the pipeline. So this is the, let me cancel this task first. So this task is run service task, and it will be using a Docker Compose file, docker compose.ci.build. So let's see what this file is. .ci.build, this one. So as I said, it will prepare the environment for you and install all the dependencies. So it is running .NET Restore, .NET Publish, all those commands that you run manually as part of preparing the environment for the build. And it is using a base image of ASP.NET Core with a certain build number. This is what this particular file is doing, and using that we are implementing this particular steps where it is. Okay, this particular step. Okay, and again we have to make a certain change. So click on settings, and basically you have to change your subscription. You have to create a new service connection for that. So you can click over here, subscription, and hit authorize. Once you hit authorize, a new service connection will be created for you, just like it is there for me, this one. Once that is there, that means it has the access to your Azure portal and its resources, and you can use the resources from there. Then you make the changes in your Azure container registry. Currently there are no results found because our resources are currently under provisioning. So let's see. Okay, it says it has been completed, so all the resources should have been provisioned. So if I hit refresh, there are 5 resource group. Okay, Day-11 demo resource group, this is the one that was created. So it has an AKS cluster, SQL server, container registry, SQL database, and this is a data collection rule. Okay, so our resources are there, but somehow our service connection doesn't have access to it. Okay, so let me just go back, okay, and hit on settings again and select the service connection. Okay, and then select ACR. It still does not show the file. Maybe I have to close this file and edit it again, because I was doing both the things at the same time. So let me just save it. It might trigger the pipeline, but that's okay for now. let's create on edit again. Okay, and go to settings of Docker Compose. Let's select this one. Okay, now it is there. So it is there in the new service connection. So demo11 demo ACR, this is our Azure Container Registry, and then it will be using the file ci_build.yaml and keep everything as default, and build repository name, yep, keep everything as default and hit add. So this will be updated over here. Now go to the next task, which is a build service task. In build service, it will build the Docker image specified in the Docker Compose YAML, and it will add the tag as well to the image. So if we go back to the repo and let's see Docker Compose.yaml, this file, right, it has a path to Docker file. Inside this particular folder, src myhealth.web, it will have a Docker file. So this will build that image for you. The image name will be this, right? And once it does that, it will also add the tag to it. So this is additional image tag, which is a build ID, right? So again, click on the settings and select your service connection, then select your container registry from there. Okay, this is the Docker Compose file. Rest everything should be default, and this is the image tag, which is build ID. Hit add. Okay, the next step is Docker Compose push service. So go back. Push service will push the Docker image to the Azure Container Registry. So first it will replace the token, then it will prepare the suitable environment with the base image, then it will build the Docker image and add tag to it, and then it will push the image to the Azure Container Registry. I'll select the settings. Okay, again, select the service connection, then select the ACR. Okay, it will use the same file docker compose.yaml, and it will have that build tag. That's it, and hit add. So it will make the changes. Now let's go to the next one, which is log services. So log services, okay, it does not say what log services does, but let's look at the pipeline code. The log service will generate a dedicated compose YAML that we can use in the release pipeline stage, right? So this will, you see there is another parameter which says output docker compose file, and it will have all the details to start the container, including the image name and everything, right? So again, make the changes, go to settings, subscription, which will be the new service connection, select ACR, okay, and rest everything is default. Hit okay. Then once that is done, then you need to copy the files to the artifact staging directory so that it can be consumed to the release pipeline. Then once that is done, you need to transfer the files, the YAML file in which the tokens are replaced, and the DACPAC file. So if you are looking at this DACPAC file for the first time, so this is a compressed package version of all the database objects. So because we are building our database from scratch, it will create all the tables, indexes, basically all the database objects, and this is part of the build itself, right? So these two files along with the Docker Compose file will be part of the build. So this will copy the file. Yeah, we don't need to make any changes in this step. Then we have the publish build artifact. So this will create an artifact named deploy and then publish it to a artifact repository. So this will create a new artifact which is by the name deploy, and inside that there'll be these three files. Okay, so these are all the changes. The only thing that is pending to do is add the variables. Now click on the variables and let's add the details. So ACR details, we can get it from the Azure portal itself. So our container registry name is this, but we need to add the complete login server name. So go to that repository, registry, and there is this login server name. Just copy that and go to the pipeline, paste the value over here, hit OK. Then the next is SQL password. Okay, SQL password, I believe copy it from here. This is the test project that I created. So copy the value from here, password, we'll use this, then SQL Server. So SQL Server, go back to a resource group, and inside that resource group there'll be a resource SQL Server. So this is our SQL Server, and we need this fully qualified domain name. So just copy that and paste it over here. Then we need the SQL user. SQL user, I believe this one was check SQL user. Yeah, it's SQL admin. Okay, and hit OK. So we have added all the variables, and let's go back to a repository and see if we missed anything. So we updated the service connection, we updated the token pattern, the pipeline variables, and that's it. Now we can just save the file and it will auto trigger this pipeline. Okay, let's go to pipeline, and why it did not trigger the pipeline, I'm not sure. So let's click on edit, and trigger is there on master, but I guess repos have main branch, right? So the trigger is wrong, that's why I did not trigger it. So let's update it to main and hit save. Okay, hit save. Now it should trigger the pipeline. Go to pipelines. Okay, it triggered the pipeline. So it will take okay, before that it needs the permission. So let's select on view and hit permit, give it a permission to execute the pipeline, and hit on job. It will take few minutes to complete the pipeline. So I'm going to pause the recording and then I'll come back and see the next step. Alright, so our job has been completed in like 2 minutes 20 seconds. So let's see what it did. So first step was replace token. So it says replace 3 tokens out of 3 in one files. So in app settings.json, which has the SQL server details like SQL user, SQL password, SQL server login details, those 3 tokens have been replaced. The next was replace token in the YAML file. It has 1 token, so it replaced that as well. Then run services, preparing the environment, restoring packages and everything, installing those packages, it was completed. I don't see any errors. Then the next one was build services, in which it built the Docker file, I believe. Yes, it did. It built the Docker file for us using the Docker Compose YAML, and then it pushed the Docker file to the ACR with the tag as the build ID. It did that as well. So here is our repository, and 152 is the build ID. Then log services, it publishes the Docker Compose YAML to be consumed by release repository. And then we have copy files, which copies the file YAML and DACPAC file to the staging artifact staging directory. Then it published the artifact to be consumed by release repository inside the deploy artifact repository. Right, so if we go back and it says one published, click on that. It had a deploy folder. This deploy folder has 3 artifacts. So if you click on this file now, okay, let me download it. So let me open this. So in that file, that token was replaced. I have verified it. I only have one screen at the moment, and it's not currently recording that particular window, so I'm not able to show you that, but you can verify that by yourself. This file will have those details. So now the next part is creating the release pipeline. I click on release and hit new pipeline. Okay, and let's start with the empty template. That's okay. So first we need to add the artifact, so click on that, and we'll be consuming the artifact by the build itself. So select the source pipeline demo11 AKS, and yeah, so this is the latest one. Click add. I'm just fast forwarding it because we have explained this multiple times in the previous videos, so that's the reason. Now add a stage, and over here let's select an empty job. Okay, we know what we want to do, so let's give it dev deployment. Okay, and hit on one job. Okay, run on agent. Let's use the default agent details. Then add a task first for database deployment, because database has to be deployed first, so that once the application is up and running, it will have the connection to the database, right? So the task that we need is Azure DevOps. So let's select the DevOps, and this is the one, Azure SQL database deployment. Okay, hit OK. Now click on that, and we'll add few details why it is okay. Now good. So select the service connection over here. This is the one. Now SQL Server authentication, will add the variables. So SQL Server, and then database will be, let me see if I'm copying it correctly or not. If I'm entering it correctly or not. So SQL Server, then database name. Don't want to misspell in the variables name, else we have to just fix it and run it again. So that's why I'm just copying it. Then SQL user, and then have a SQL password. This is correct. All right, then go down. Deployment type is SQL DevOps file. Action is publish, and the file is, let's browse the file. It will be part of the build itself. So click on browse. Okay, linked artifact 𝗲𝒂𝒂𝒏𝒆 deploy, and here is a DevOps file. Select that, hit OK. Might have accidentally pressed it twice, so close this, and rest everything we can leave as default. All right, now add the next step for Kubernetes deployment. So basically you need to search for kubectl task, this one, and hit add. Now select the service connection as ARM, select the service connection, then select the resource group, then select the cluster, and then select the command. So we need apply command. Okay, now go to secrets, and we basically needs to create a secret so that it will be used while pulling the image from the ACR. So select the secret type as Docker registry. Registry type is ACR. Select the subscription service connection again, and then select the ACR. Okay, let's give this a name. Let's call it secret. Okay, and that's it. So we had made the changes. Again, we need to make a few changes, which is variable. So I'll just add the variables from here. So the same thing, we need ACR, paste it over here. Then we have database name, D in capital N. Then the third one is SQL password. SQL password. Then we have SQL server. All right, then we have the last one, which is SQL user, SQL admin, SQL user and admin. All right, so everything is good now. Hit save, and then we'll deploy this release pipeline now. So go to pipeline, Now we have verified this. This is good, and both the tasks are okay. So now I hit create and select the stage and hit create. Release has been triggered. Now I'm gonna pause the recording till it is getting completed. Oh, before that we need to hit deploy because this is a manual trigger. Okay, now I'm gonna pause the recording and I'll be back and for the further steps. So the pipeline actually failed because I forgot to specify the YAML file. So we need to hit over here, use configuration and upload the file path over here. So the deploy folder and then 𝑚HCAKS.yaml, hit OK. And I believe this will be good now. Quickly verify. File path. Okay, yeah, this is good. And we had one more step which I forgot earlier, update image in AKS. So this will basically update the tag, the AKS. So I'll just copy this command from here and update image in AKS. Again, this will be a kubectl task with the command as set. Okay, let's add one more kubectl. Okay, service connection should be ARM type service connection. Then select the resource group, select the cluster. Command is set argument. Okay, so it will be running kubectl set image and will update the image in the manifest itself. And we need to do the same for secret over here. So select the Azure service connection, container registry, and secret name it as itself. So save. Okay, I'm gonna run the release again and I'm gonna pause the recording again. Sorry about that. Deploy and hit deploy. Alright, this time the job has been completed. So let's see what it did. First, it downloaded the artifacts. So I don't see any error. It says successfully downloaded 3 artifacts to this particular directory. Then it ran the DACPack task. So DACPack, if you see, it actually did the table import. It enabled the indexes. It added the check constraints, and it added a lot of other database objects as well. So the DACPack task has been completed. A database was built, and then it ran kubectl apply command. This command we use to apply resources with the help of a YAML file. In our case, it was 𝑚HCAKS.yaml. So it created a secret of type Docker registry, and it created the secret against that particular Docker registry. And then it applied the YAML, and this has been completed. kubectl apply was completed. Then the next task was kubectl set. So it ran the kubectl set deployment image command, and it actually updated the image from deployments MHC front to Day-11 demo, which is our Azure container registry name, and it tagged the image with the build number as well. Right now, the last part is we need to check if it was completed or not. So by the way, this was our YAML, right? And here you see image. When we looked at this earlier, it was ACR. This file was tokenized. Now the token has been replaced with the variable values. Right? So this was completed. Now let's go to our Azure portal. Okay, and in our Cloud Shell, first we need to log into the cluster. So I'll go to the resource group, Kubernetes service, and then there'll be an option which says connect, and it will display a Cloud Shell command for you to log into the cluster, right? So scroll down where it says download cluster credentials, copy this, and just execute this command in your Cloud Shell. Paste, and it will basically, okay, I'll just overwrite the file. It will set the context to this particular directory. The kubeconfig has been generated with this command, and in kubeconfig it has the details to log into the cluster, right? So now you can run commands like kubectl get nodes. For the number of nodes that this cluster has, it has 3 nodes and all the nodes are in ready state. The cluster version is 1.27.7. Then you can run kubectl get pods. So you see there is one front end pod and then there is one backend pod. However, the backend pod has an image pull error. Not sure why that is. So let's just look into this. kubectl describe pod and the name of the pod. Okay, I have misspelled it. So kubectl. Okay, so the error, it says Day-11 demo ACR dot Azure CR. It says failed to fetch anonymous token. It's getting failed to authenticate, so it's not able to pull the image. Okay, so after spending an hour or so, I was finally able to figure out the issue, and finally the deployment is up and running. So I'll explain you the issue. So if you go to the release pipeline, you would see inside the advanced option there is a kubectl version specified. So by default, the version specified was 1.13.2 of kubectl, and the kubectl version that comes with the AKS cluster, it was different. So because of the version mismatch of kubectl, it was giving that error. So what we need to do is we just need to check this box which says check for latest version, so that it will deploy the latest version as per the AKS cluster and it will be sorted. And we need to do the same thing in the next command as well. So inside advanced, just select this box, and finally the deployment is up and running. We could see that both the pods are up and running and the deployment is up and running. And if you remember correctly, we exposed this particular deployment for the front end. We exposed this with the help of a external load balancer service, right? So you can do kubectl get service or get svc. Those are the same thing. So you would see two service of type cluster IP. That is how the pods are connecting to these other pods internally with the help of cluster IP. And then we have a front end service which is of type load balancer. That means that is a service that has been exposed externally with the help of an external IP. Application will be listening on this particular port. So if you copy this, what I mean is our application will be listening on this particular IP, and which is a public IP. So if the copy this and open this in a new tab, so here it is, our application which is accessible, and it is accessible on port 80. And there are a lot of options that you can select, like this is a fully functioning app. You can log into it, with the help of default username password. I don't have it at the moment, and you can check the code to find it. And basically once you are able to log in, you can connect with the database. You can get the patient information from the database, because we already deployed a database object, so it will have some default entries in the database. So you will see all those details, right? There are some page that is not working because I'm not sure why, but that is not our concern. Like, as a DevOps or a cloud engineer, our main focus is not for the application code, but how are we packaging it, how are we deploying it, how are we making sure of security and all other things. So this is all good. Now the important steps that you don't forget. So in the same GitHub repository, if you scroll down, there is a destroy the resources kind of section. So make sure you run this script to deploy all the resources that were provisioned with this particular demo, so that you stop incurring cost, right? So I just copied it and in my demo directory, demo, I'll create a new script. Let's call it delete.sh. I'll paste the content over here, and it has basically the same variables. It is using the same _cli commands, so it will just delete all the resources that were provisioned. So I'll just, okay, I'm not sure why it is throwing the error. Let me quickly verify it. So I'll go to the first line. Why it is throwing error for this? Okay, I'm not sure, but let me just user bin bash. I'll just replace this, the bash executable. It is still throwing that error, but it's okay because it is doing its work. It is proceeding further, and it will ask you few more prompts because we are doing the destruction operation. That is why. So once that is done, or you can just directly go to your resource group and delete this resource group, but there will be one more resource group created, so you can delete that as well, this one, right? Because for worker nodes there will be separate resource group created, so you have to delete these two resource group, and that should be good. So that's it about the demo. Thank you so much for watching this video till the very end. I'm sure this was helpful to you in understanding Kubernetes basic concepts, and you were able to implement this project end to end by your own with the help of Azure DevOps CI/CD pipeline. You can share your progress with me on LinkedIn or Twitter, and I will gladly provide my feedback on this. If you face any issues, you can always comment on this video, and I will try to help as soon as possible. We also have a Discord community, and link is there in the description, so do check that out. There is a dedicated help channel for Azure DevOps. You post your queries on that, including all the information, and someone will help you out as soon as possible. If you are new here, consider subscribing the channel. If you are a regular visitor, please give it a thumbs up. It will help to promote this video and to reach to maximum audience. So thank you so much for watching, and I will see you soon with the next video.